Hi everyone, this is Dr. Ekta with you. So in this video of mine, I'll be talking about IUPAC nomenclature of coordination compounds. Though in the previous video of mine, I had already taught the nomenclature rules. But here I thought let me give you a few examples so that it becomes pretty easy for the children to understand. So let's get started with the nomenclature. Well, the first compound is right in front of you. Let us see how we should go ahead with its nomenclature. As I said before, the first thing is to write the names of the ligands in alphabetic order. And to write their names, you should be thorough with the table which I shared in the video part 2, right? So if you have not seen that, please get back, watch that, and then sit for watching this one too. Fine. Now let us get started. So the first ligand you can see here is your amine, then it's aqua, and the last one is chlorido. So we go alphabetic order. So first I'm going to write here amine, right? Correct. Then comes aqua, then is your dichlorido, fine, and then comes your name of the metal atom, that's platinum. Now we also need to figure out its oxidation state. So how should we do that? If you remember, I told you if the coordination complex doesn't carry any charge, it means there is zero charge. But the convention is we should not put any charge. So platinum is X, amine is neutral atom, so zero charge. Aqua water is also zero, but yes, chlorido has -1 into 2, right, is equal to 0. So X minus 2 equal to 0, so X comes as 2. Here we go. So the oxidation state of platinum comes as 2, which is written in Roman number. So that's how we get to write the IUPAC nomenclature of this particular compound. Hopefully it's clear to you. Let me take another example for you. So here we go to the next page. Fine. Now let me give you another example of, well, K3FeCN6. So this is a coordination compound which we are going to discuss right now. Again, if you see this coordination compound, the rule is the same. First to write the cation followed by the anion. So yes, potassium is a cation, though it's an ionizable ion, right? And this entire complex is anion. So the first thing is to figure out the charge on this complex. Now potassium, K is +1. But how many atoms are there? 3. So that means the total charge on this cation comes as +3. So of course the complex should develop -3, right? Now to figure out the oxidation state, let us first find the oxidation state of iron over here. So I'm going to put it as X plus cyanide is -1 into 6 equal to -3. So X would be -3 plus 6, that comes as +3. Wow, that's great. So this is how I'm going to find out the oxidation state I found. And next thing is how to write the nomenclature. So I have to figure out the ligand. So what is the ligand here? Cyano. But if you remember, while writing the nomenclature, the rule is to first of all write the cation present here. So as I mentioned, the cation is potassium. So I'm going to begin writing down here potassium, right? So this is potassium for me. Then comes the prefix. It's hexa for this ligand. So I'm going to write hexa. Ligand is cyanido because it's a anionic ligand. So it should end with O. And I'm not going to write it as iron but indeed I have to use 8 after its name, and its name is derived from its Latin name, right? So it becomes ferrate, and this I have already mentioned in the video of mine that 8, why to write this, signifies that the complex is anion. So now what is next left out is the oxidation state, which has to be written in Roman number. So here I found the oxidation state as +3. So I'm going to put it as Roman number 3. So that's the IUPAC of this complex. Hope you understood it. Fine. Now let us take the next very example. Let me set this for you. Let me go to the next page. All right, children, let's write the third example for you. Let me give you the example of cobalt, En, right? Okay, hold twice, Cl2. And this complex has a plus charge with it. Now, how to name this complex? You can see here there are 2 different types of ligands. So it's a heteroleptic type of complex. Now, in such complexes, we can even see one ligand as didentate. That's ethane 1,2 diamine, and the other one to be called as chlorido. As already mentioned before, for ethane 1,2 diamine, we can't use the prefix di. We have to use the prefix bis in this case, since there are 2 molecules. So I'm going to get started with it. Let me write here bis, put a hyphen, take a round bracket, ethane, right, 1,2 diamine, fine, round bracket close. For this chlorido I can use, yes, dichlorido I'm going to use here, and the metal atom is cobalt, fine enough. Now I have to calculate the oxidation state for it. So how I'm going to calculate the oxidation state or oxidation number? Again the same thing, cobalt is X, ethane 1,2 diamine is neutral, so 0 into 2, and chlorido has -1 into 2, and again +1 charge because the complex has plus charge, that means +1. So X minus 2 equal to +1, so X lands up as +3, fine enough. So I'm going to get the oxidation number as 3 in Roman number. So this is how we have to write the IUPAC nomenclature. I suppose it is pretty clear to you. I would also like to give you another example. So let me set page for you. Here we go. Okay, so here is my next page. Now this is the 4th example we are working upon. It's CONH3 whole 5 NO2, right? And outside the coordination sphere I have taken NO3 whole twice. Fine. Now here you can even understand how to write the primary valency. So first of all, I understood very clearly looking into the complex that the complex is cation because it's written first followed by the primary valency. So primary valency is the anion. So first of all, we are going to write the IUPAC for the complex because it's a cation. And we already know for writing the nomenclature of the complex, we begin writing with the ligands. So in the alphabetic order, of course. So the first one for me is amine and it is 5 here. So I'm going to use the prefix as penta. So see here, we are going to write it as penta, right? Amine, so A-M-M-I-N-E, amine. Now it's nitrito because it has a negative charge and all anionic ligands should end up with what? O. Another important thing in this case is nitro, if you remember, it's an example of ambidentate ligand. That means such type of ligands wherein it has two different atoms to coordinate, right? And two coordinating atoms coordinate with the metal bond at different time. So here the coordinating atom, I'll just put a asterisk over here, it's nitrogen atom. So see how I'm going to write here, it's nitrito, fine, N, because N is the atom in nitrito which is coordinating with the metal atom. Then comes cobalt, yes. Oxidation state I'm going to find out, so I'll just put a round bracket here, and it's the nitro, okay. Nitrate, now I'm not going to use it as nitrito, because nitrito, if I use, it acts as a ligand, remember this. Now this is not a ligand for me, it's a primary valency, which I made it very clear in Werner's theory. So I have to write this primary valency as nitrate. And please take care, though there are two molecules of NO3, but I'm not going to use any prefix with it. Remember, I repeat again, no prefix should be used for primary valencies. Now, what is the role of this NO3 whole twice? Yes, it plays a vital role. Because of this only we can decide the charge on the complex. And if we don't get to know the charge on the complex, we can't find the oxidation state of the metal atom here. So as I know that NO3 is carrying 1 minus charge. And how many molecules are there? 2. So the total charge on the primary valency comes as -2, right? Yes, so it is -2. So as I told you, the complex should have the opposite charge. So the charge on the complex should be +2. That I could find out with this. Now it's pretty simple for me to figure out the oxidation state. So how to find the oxidation state? Let me utilize this space. Again, cobalt, I'm going to put it as X plus, yes, amine is neutral, so 0 into 5. And nitrito has -1 charge, and I'm going to put it equal to +2, sorry, because it has +2 charge over here. Fine. So X comes as +3. Wonderful. So here I'm going to cite the oxidation state as +3. That's in Roman number. I have written here 3. So this is how we write the Iupac nomenclature. Hopefully it might be pretty clear to you with 4 examples. Okay, fine. We'll go ahead with writing the formula, though I wrote one formula for you in video part 2, right? So we are going to share few more examples with you now. Okay, we get started with writing formulae of complexes. So here I'll give you a few examples to make it very clear. Let me write the first one for you. So here the situation is just the reverse of nomenclature. Like, name of the complex is given to you and you have been asked to write the formulae. Okay. Suppose the name given to you is, I'll write down here just a while. Yeah, here we go. Tetrachlorido, okay, tetrachlorido cuprate 2. That's the complex name given to you. How are you going to do this? It's very simple. Again, as I said, in nomenclature, it's first the ligands followed by the metal atom. But when we write the formulae of the complexes, it's just the reverse. First, we need to write the metal atom followed by the ligands. So what's the metal atom here? We can highlight cuprate. So I'm going to use square bracket Cu cuprate. Now another important thing you might have noticed, if you remember, I told you that if you have 8 at the end of the metal atom, right, it signifies that the charge on the complex is negative. That means, in other words, it's an anionic complex. So we also get to know about this, right? So now what's the ligand over here? Chlorido. And it's tetra. Tetra means 4. So I'm going to use Cl4, right? When I use the Cl4, again I have to close the square bracket. Now I have to cite the charge on this complex. For writing the charge on the complex, I need to use the oxidation state. Now right now the oxidation state is 2. That means copper has +2 state. Plus chlorido means -1 into 4, right? So what's the number you're going to get? You are going to get -2. So that's the charge on this complex, which I have to write it as -2. So this is how we write the formulae of the complexes. So this is one example for you. Hope I made it clear. Let me take another example for you. For that I have to set the next page. Okay, here I go. Next example for you, I would like to give you, let me take something different for you. Okay, fine. We'll go with potassium. Okay, potassium tetra. Let me make it a little bit different. Okay, potassium tetra hydroxo. Okay, and the metal atom is zincate 2. Fine. So that's what I have written down here for you. Now in this case, if you see, the ligand is hydroxo, right? Again, the metal atom is ending with 8. So I get to know that the charge on the complex has to be negative. And potassium is a cation over here. So how do I write? So writing the formula, I told you, whether it's a formula or the nomenclature, we have to first cite down the cation. So cation here is potassium, K for you. I don't know what is the number of potassium, so I leave it right now. I'm going to come back to this point, put a square bracket, use zinc, Zn, the symbol for zinc metal atom, and the ligand here is hydroxo. Okay, that's hydroxo. That means OH group. So I'm going to put this in round brackets, and it's tetra. Tetra means 4. I'm going to close my square bracket. That's the complex. But what about the charge on this complex? The charge can be calculated by using the oxidation state. So oxidation state of zinc is what? +2. OH is a ligand with negative charge, -1 into 4. So I'm going to land up with -2, right? So that's the charge on this complex. And potassium, I know it's K+. Each potassium has +1 charge, but I have to counterbalance the charge. So since the charge over here is +2, so what to do? What should be the number of potassium over here? So potassium should be written as 2. So the formula of this complex I got as K2ZnOH whole 4. Once you are done with this, no need to signify this charge over here. So I'm going to erase it, because while writing the complexes, we should not specify the charge in case the primary valency is not mentioned, then you need to mention the charge. But here primary valency is there, right? Ionizable cation. So there is no need to mention the charge on the complex. Hopefully with all these examples, it is clear to you how to write the nomenclature as well as the formula of the complex. So that's all for this video. Keep watching, because in next video the topic would be isomerism. Thank you all.